Hello everyone, welcome back. Today we're going to continue with what we were doing last week. We watched basically congruence and similarity, and last week we finished with logic, but let's just get to it. Let's see exercise 8. So it says that in this diagram, JKL is similar to triangle STU. So remember, so the first letter is going to be similar to the other first letter, so J similar to S. It like is equal in the angle, K goes with T and then L goes with U. So L, which is a right triangle as it says here, goes with U. Now, based on the measurements in the diagram, what is the measure of angle K? Well, in similar triangles, their angles are equal to each other. So we can say that angle K is equal to angle T. And we have all the angle K equal to angle T. And we can look we can solve for angle T. So we can say T plus 60 plus 90 because this just means 90 degrees plus 90 is a 60, wait, equal 180. And T plus 150 since 60 plus 90 is 150 equal 180. T equal 180 minus 150 is 30. So K will also be equal 30. Wait, better. Now let's see. Now here triangle STU is congruent to triangle WXY. So S goes with W. That's going to be my first step always. T goes with X. And then U goes with Y. So U and Y. Now, where are the values of X, Y, and Z? Okay, so let's solve first for X. Now we know that this angle right here is also going to be equal 92 because X equal 92. So we can say that 65 plus 92 plus X equal 180 because all the interior angles in a triangle are equal 180 degrees. I have 65 and 92 and X. So 65 plus 92 is going to be equal 157. So 157 plus X equal 180 if you want to make sure. Oops. Wait. Here. So 65 plus 90. 92 was, see 157. Yep. And then we start 157 from both sizes and we get 180 minus 157 is 23. And if you want to check, 23. So we know that X is 23, and we have it here and here. We can get rid of this too. Now let's see what is Y. Which one is Y? Okay, we have Y here. Then we also know, SU is going to be equivalent for WY. We're going for the purple to the orange, from the purple to the orange. That's the reason I like to use colors, because it's easier to visualize it. So, therefore, we can say that 2y plus 5 is going to be equal to 25. Let me check something. Does this... Okay. Now, we can subtract 5 from both sizes. We get 2y equal 20. 25 minus 5 is 20. Then we divide by 2 and we get that y equals 10. We can get rid of these two and we know our answer is D. But let's make sure that C is correct. So again, here we are going from the blue one to the orange one. Here we are going from the blue one to the orange one. So we can say that 18 equal 15, 5z plus 3. So 18 equal 5z plus 3. We subtract 3 in both sizes. So 18 minus 3, 15. 3 minus 3, 0. So just 5z. And then we divide by 5. And we have the z equal 15 divided by 5 is 3. That's what we got. So that's our answer. Now let's see 10. Okay, I see I don't have the triangles. So I'm going to draw the triangles here. Have two similar triangles. Okay, now I have the triangle. Oops, wait. E, F, G, and J, K, L. And I have the E goes with J, F goes with K, and G goes with L because of the order. Now we also know that E equals 32 degrees, so 32. K is 49, so 49, oops, 9. They're asking what is the measure of F. As we see, F goes with K, so F is also going to be equal 49. Let's continue. Given the triangle shown, find the value of X. So here we have a 3a, and we also have a 3a here. Now, we need to either prove this is 74 or this is 68. So we can use either of the two. I can say that 68 plus 38 plus b, because that's angle b, equal 180. 68 plus 38, 106 if I'm not mistaken. Let me check. Oops, my bad. 106, yes. So 106 plus b equal 180. We subtract 106 6 from both sides. We have the b equals 74. So we can say this is 74. So this is 74 as well. And now we know AA, the definition of similarity, angle. So we can say that this is also we have because we have two similar angles in these triangles, they are going to be two equal angles in this triangle, they're going to be similar. So this one is going to be similar to this one, therefore this is also 68. Now they're asking to find the value of X. Now we proved that they are similar, not that they are equal. And also we know that this side, the blue, dark blue to purple, it's going to be equivalent to the dark blue to purple. This is 5 and this is 25. So they're definitely not congruent. You're similar. So I can say 5 is a 25 as 3x plus 4. Now 3x plus 4 is dark blue to red. So I'm gonna go dark blue to red. And this is going to be 5x plus 6. Now before cross multiply, I'm just going to say well, either way. So we cross multiply, and I'm going to say 5 times 5x plus 6 equal 25 times 3x plus 4. Now 5 times 5 is 25, so this 25x plus 6 equal 25 and 3x plus 4. Now if we divide both sides by 25, I'm just going to cancel out them, and we have x plus 6 equal 3x plus 4. I'm going to subtract 4. Wait, let me write it so you can see it. subtract 4 in both sides, and subtract x. So I can say 6 minus 4, 2, x minus x, 0, 3x minus x, 2x, 4 minus 4, 0. And then we divide by 2 both sides, and we get that x equal 1. And that's our answer. And the only thing I did was, I can, like I say, the small one of this triangle, like the blue one of this, okay, let me put a color. The light blue one of this triangle is equivalent to the light blue one of the similar triangle, as the middle blue one of this triangle is to the other middle blue, to the middle blue one of the other triangle. So, because they're similar. Now let's see this. Quadrilateral QRST is shown with side lengths in inches and angle measures in degrees. Line draws quadrilateral WXYZ, which is similar to quadrilateral QRST with, okay, let me draw it. Try to do the right one. That's the best I could do. This is going to be, okay. W goes, okay, W goes with Q, so W. X goes with R, so X. Y with S. And then T with Z. So this is going to be, this is going to be 90, this is 90, this is 135, and this is 45. Now, similar figure have equal angles and a specific ratio for the sides. So one side over the other, over its equivalent side, give a specific ratio. Now, line draws quadrilateral, which is similar, and WX equal 5 inches. So WX equal 5 inches. So it's actually bigger. 5 inches. Which is similar. Okay, select all true statements. WZ equal 15 over 2. So let's see. We're looking WZ, which is this side. So I can say that WZ is a QT, this is the equivalent, QT, as WX is a QR, is QR. Why? Because I'm saying this one side of this is as the equivalent side of the other one, as the other side of this is to the equivalent side of the other one. So that's all I'm saying. Now that I have this, let me copy it here. I have to make it really small. So I don't know WC. I'm gonna leave WZ as that. Now, do I know the value of QT? Let me check. QT is 3, so I'm going to put 3 equal to WX. WX is 5. And QR is 2. Now, if I cross multiply, I have 2WZ equal to 3.5, which is 15. And then if I divide by 2 both sides, I get the WZ equal 15 over 2, which is the same. So this is true. Now, measure of angle Z equal 45. No, we know that angle C goes with T. T, the last one, goes to the last one. So it's 90 degrees. So nope. ZY equal 25. So now we need CY. We repeat the same process. We say ZY is its equivalent side is going to be TS. We have WX, so WX is QR. It's exactly the same process. So we have ZY is a TS. TS is 5, so 5 plus WX, which is also 5, is QR, so QR is 2. Now we cross multiply, so we say 2 ZY equals 5 times 5 is 25, and then we divide both sides by 2, we have ZY equal 25 over 2. And that's not what we get. We have 25 over 2, not 25. Now let's see. Now they're asking for a measure of angle X, and what was the measure of angle X? 135. So we are right with that one. Wait. Okay. Now we need the area of the quadrilateral. Now to do that, we just need the height and these two bases, and we just calculated that. We calculated that WZ equal 15 over 2, ZY equal 25 over 2. So the area of this is going to be base 1 plus base 2 over 2 times height, because that's the definition, and that's the formula for the area um of a quadrilateral, no, of a trapezoid. And we, like, this is a trapezoid, a rectangle trapezoid. Now we have the bases. The bases are going to be 5 and 25 over 2, so 5 plus 25 over 2, all this over 2, times the height. The height is just this because it has two 90 degrees angle. So times the height times 15 over 2. Let me make this smaller. So 5 plus 25 over 2. Remember, we are additionating, so we need a common denominator. So we're going to have 2 as our common denominator. Then 2 times 1, 2. 2 divided by 1, 2. 2 times 5, 10. 2 divided by 2, 1. 2 times 1, 25, so plus 25. Now 10 plus 25 is 35, so 35 over 2. So here we have 35 over 2 times 15 over 2. Now if I say 35 over 2 divided by 2, remember when we are dividing and we have a fraction, we need to multiply by its reciprocal. So this is going to be 2 over 1, so we say 35 over 2 times 1 over 2, which is the reciprocal. And then we here, since we are multiplying, we say we say 35 times 1 is 35, and then 2 times 2 is 4, so 35 over 4. So this is going to be equal 35 over 4 times 15 over 2. So we just multiply again. We have 35 times 15. We go to our calculator. So 35 times 15, which is 525. I don't know what I opened there. So 525. And then 4 times 2 is 8. That's our area. And that's what they say. So yep. This right here is true. Now let's check the next one. So triangle M and O is shown. Which triangle can be shown to be congruent to triangle M and O with only the given information? Now, first, in this one, we're only seeing angles. This is going to be similar, but it's not going to be congruent. In this one, we're only seeing two sides. We are not seeing the angle. So there's also, the formulas, the congruence properties or theorems are SAS, ASA, and SSS. So angles are enough. Angles alone is not enough. Two sides is not enough. Now here, we're saying S side, angle, and SSA is not a property. So we do not have enough here. Here was you can see, you can see this S, this A, this S, so it will be SAS, which is one of the properties we're looking for. So our answer is going to be D. Now see 14. Okay, let me check this. We do not have the quadrilateral here, so I'm just going to draw it. We have a quadrilateral here. This is going to be S, T, U, B. And we have another one here. I know that S go with G, so G. T with H, so H. I, J. So I draw the colors. This one goes with this. Oh, this one goes with this one. Here, here. Here and here. Here and here. Okay. Now, let's say that SV is X plus 1. ST is 3. UV is 4. GJ is 17.5. GI is 10. Where is the value of X? Okay, now we know they are similar, so you're looking for this value. So I know this side is going to be proportional to this side right here. We're going to dark blue to yellow, from dark blue to yellow. So I can say x plus 1 is to 17.5 and we know that this side is also proportional to this side, so 4 is to 10. So I cross multiply, I have 10 x plus 1 equal 4 times 17.5. Now 4 times 17.5 is 70. Oops, again. So I have 10 x plus 1 equals 70. Now, if I divide both sides by 10, you know how to do this. These will just cancel out because they're multiplying. So I have x plus 1 equals 70 divided by 10 is 7. And now I subtract 1 from both sides, and I have a x equals 7 minus 1, which is 6. And that right there is our answer. Okay, I need to do this straight. Enough. Now here, again, we're given two triangles, but we are not given the triangles, so we're going to draw them. Okay, they are not similar, never. Okay, now, we have triangle DEF similar to JHI. So D goes with J, E goes with H, F goes with I. First one with the first one because of this order. Now we have the D equal 50, E equals 2 plus 5y, G equal 102 minus x, and then H x plus 15. So first let's solve for x. Now we have the D is equivalent to J, so I can say that 50 is going to be equal to 102 minus x. Now I can add x to both sides and subtract 50. So plus x and then minus 50. So minus x plus x is cancel out, 50 minus x is cancel out, and I have that x equal 102 minus 50, which is 52. And I can get rid of this and this. Oops, and this. So we have that x equal 52. Now they're asking for y. Y is right here. And I know that E is equivalent to H. So I can say that 2 plus 5y equal to x plus 15. But we know the value of x. X is 52. We use calculators, so I can say 52 plus 15. Now, 52 plus 15, so 2 plus 5y. 52 plus 15 is going to be equal 67. And then I'm going to subtract 2 from both sides. I have 5y. This cancels out. Equals 67 minus 2 is 65. And then if I divide by 5, if I divide by 5 both sides, I get that 65 divided by 5 is 13. And that's my y. So I can get rid of this. And I can get rid of with this. We are in the same. So let's solve for I. Now, here we have the value of y, which is 13. So I can solve for e. So 2 plus 5y. So 2 plus 5 times 13 equal to plus 5 times 13 is 65. And 2 plus 65 is 67. So this is 67. And we are looking for I. I is equivalent to F. So I can say that 50 plus 67 plus I equal 180. So 50 plus 67 is 117. So 117 plus I equal 180. And 180 minus this I. 117 is equal 63. So we take away the 67. We are left with B. Now let's keep going. Let's do 16. Given AD is equal to ZD, which statement is sufficient to prove that ABD? So we want to prove this. A, B, A is with C. This is what we want to prove. B is with obviously B. So it will be this. D with D. So yeah. Which makes sense. D and D. Now we want to prove, so we want to make the which statement is sufficient to prove that ABD is congruent to CBD. AVD, congruent to with CVD. This, we will need this, but it's not sufficient. We only have one side and another side. We need more than that. Now, AD, con, congruent with VD. Okay. We have side. And here we also have side. Angle BAD, congruent with angle CDV. BAD, congruent with CDV. And like, actually, that wouldn't even make sense, because we want to prove this one is A is congruent to with Z. So no. And then ADV congruent to CDV. Okay. Now, which one of the three? Let's analyze it. We say this alone, this by itself, and this is congruent to this is not enough, because we only have a side and opposite angle, which is not a one of the. We want to prove they are congruent, not similar. So we're looking for either SSS, SAS, or ASA. Or the hypotenuse leg theorem, we will need two things. This to be 90 degrees and this to be equal. So this is not enough. Now, AD with BD, we will have two sides. You know, let me take the that one. Whatever. Bueno. I'm just gonna leave it. We'll have two sides, this, and then this is reflexive because it's the same. But again, it's just two sizes. We need three to prove it, so not enough now. Wait, this won't work. We are trying to prove this angle to be equal to this angle. Then it will make, if these two angles are equal and they are over the same line, it will mean that this is going to be x and this is going to be also x. So x plus x equal 180. So 2x equal 180. And if I divide by 2, x equal 90. So this is a 90 degrees angle. Now, since this 90 degree, this means, and these two are equal, this means this is a okay, since this 90 degrees, let me change it now. And these two are equal, this side is congruent to this side. It just means that this is a perpendicular bisector. Perpendicular because it's creating a 90 degrees angle right there. And bisector because this side congruent by this side. This was all given. Now, another property of the perpendicular bisectors in a triangle is that it also divides this angle in two equal sides. So this part right here is going to be equal to this part right here. They're going to be congruent. So right now we actually prove we know, like, this is the same side, like this fact right here, AD with BD. Oh no, never mind. What I wanted to say is that BD is congruent with itself, is a reflexive property. So we already have this side. So we have an angle here, side here, and an angle here we can use to prove those two are congruent. but for solving this specific exercise, you need to be very you have to have a very good understanding of the properties. So based on that, I knew that these two were 90 degrees and this was equal. I can prove this is a perpendicular bisector, and if this is a perpendicular bisector, I can prove this one is congruent to this one. And now this side is congruent to itself, so by the reflexive property. So I can prove with um angle side angle, angle side angle, this triangle is congruent to the triangle. So yeah, that's basically it. Well, we'll continue next week. We have a lot to do. So I'll see you guys. Don't forget to go on Discord and ask me if you have any question.